But he said I was flapping my arms all over the place and my strides were not large enough. I may have used a lot of energy, but I wasn't being efficient at all. I still don't really know what he meant.
Ah, let your favorite teacher help you.
Miss Jenny? But she's not here.
Well played. Anyway, let me explain what your coach is trying to tell you.
You mean about me expending a lot of energy, but I'm not being efficient?
Yes, you see, we use the term efficiency in physics quite a bit, and it's entirely appropriate in your context.
Interesting. Tell me more, my real favorite teacher.
Efficiency is all about input and output. Take, for example, a vending machine which dispenses canned drinks for $1. If you put in $1, you expect it to give you one can. $2, two cans. So that's a 100% efficiency.
Makes sense?
So with regards to energy, it is about energy inputs and outputs. We ask the same question. Does energy output equal to energy input?
But isn't energy always conserved? In that case, why would input and output differ?
Before I answer your question, let me ask you another question. When you plug in your laptop's charger and you turn it on, what would happen to the charger after some time?
Nothing happens?
Really?
Besides getting hot, I can't think of anything else that is different.
Exactly. It gets hot. Some of the input, which is the electricity coming from the socket, is used to charge the laptop, while some of that electrical energy is converted into heat.
Oh, I remember. This heat is an unwanted form of energy.
And what do you think is the reason why the energy output is smaller than the input?
This is because energy is lost in the form of heat energy, which is unwanted. Thus, the output must be smaller than the input.
Good. Let us see what the others think.